Hey, welcome to Pre-Cal. I miss saying that to you guys and I hope you're all doing well. I miss having you here in class. We're going to jump into our next lesson, which is lesson 4.7. And so we spent a couple of lessons doing a whole bunch of graphing of trig functions. Maybe we enjoyed that. Maybe we did not, but you're a whole lot more educated and knowledgeable than you were a couple of lessons ago. One of the things that we've done all year with functions is we've discussed the inverse of those functions. And I'll just remind you, since I can't pick on you and call on you, that the inverse of a function really means taking the x and the y value and switching those two. And the way that we would find an inverse of a function, we'd write the function out, and we'd switch the x's and y's, and then we would solve for y again, because initially it was solved for y. After we switched them, it was solved for x, so we had to do some rearranging. And there's been times that we've seen, oh, that gets really tricky when we did exponential graphs and then switch the x and the y. We didn't know how to solve that. We kind of had to create this new way of doing math, new way of talking about it called logarithms. We've got something similar going on, and I wrote a really basic trig function on the board, which is a good starting point. By the way, let me just tell you this about this video, the first video in lesson 4.7. Number one, I hope that you are watching with a clear and focused mind. If you're just getting out of a sleep or something, might want to go get a cup of coffee, because it just takes your focus to kind of wrap your brain about what we're talking about. Number two, I think it's a good idea if you have your trig wheel nearby. Remember, a week or so back, we built those trig wheels and we labeled them. And that's going to help us just kind of be able to reference really quickly what we have going on here. So pause the video if you need to, get yourself awake, do some jumping jacks, get some more coffee. And make sure you get a copy of the notes for today's lesson. Make sure you get a copy of the trig wheel, and we'll talk through all this. So if I had this function, just a reminder of exactly what it means. X represents some angle, and I take an angle. Let's say the angle that I take is pi over 6. That's 30 degrees in the olden days, but you guys know it in radians is pi over 6. I put that in there. And then to find y, I'm supposed to find the sine of pi over 6. Turns out to be 1/2. So when x is pi over 6, y equals 1/2. And, you know, that's nice and easy. And we learned how we could put those corresponding values on a graph, and we could graph a sine function. Well, the reason that we have to do inverse functions, what if I had the other information? What if I knew that I had a sine value of 1/2, and I wanted to know what angle went with it? That's why we have an inverse. If I have not the information I'm used to starting with, I have the information I'm used to kind of finishing with, and so we would swap the x's and y's, and so it would look something like this. X equals sine y. Again, that's saying I know the sine value. I want to find out what the angle is. And actually, so we've already had situations like this. You guys might remember when we were doing right triangles and doing some SOHCAHTOA, we had a couple of practice questions where we had to figure out an angle. We could do the opposite over adjacent or something like that. Remember doing it with tangent. We could figure out what the tangent was, but we needed to know the angle. All right. So in this case, it's like I know what the sine is. I need to know the angle. And so I switch my x's and y's, and now I want to solve for y again. And algebraically, I'm kind of stumped. I want y by itself. Some people suggest, well, can't we just divide by sine? But the thing is, sine never goes just by itself. Sine is attached to something. And in this case, it's attached to y. And if I divide it by sine y, then I don't have it solved for y. I'm still not figuring out what y is. And so I don't know kind of how to undo that sign to bring it to the other side. And that's the point of today's lesson. There's a concept called, it's called inverse sine sometimes. The only reason we might avoid that, we think, well, inverse of sine means 1 over sine, which is cosecant. Not talking about that. And so we might want to avoid the inverse sine just to be avoiding confusion. It's also given the term arc sine, okay? And it's given a symbol also. All I can do to move this word sine to the other side of the equation is to write it raised to the -1 power, which again is a symbol for an inverse or a 1 over, but it doesn't mean that. It means, and it's called arc sine. And so I've kind of, when I do that, I've separated it from the y. I put it over this way. So now this says y equals arc sine or inverse sine x. And the way that you would read that, this is in the notes and it's really important so that you don't get confused. Y is the angle whose sine is x. Okay, y is the angle. We know the sine value and we're going to go backwards. That's what this arc sine or inverse sine is. So y is the angle whose sine is x. All right, and we can do this for cosine. We can do it for tangents, cotangents, secants, cosecants. We have these arc functions where it's just like, I just want to go backwards. I know what the final value is, and I want to find an angle that's associated with it. Now, there's a little problem that comes with this. And again, I don't know if you totally remember or not, but inverse graphs, when we do the inverse of a function, it essentially kind of turns things sideways. The x and the y swap places. So it's kind of like if we swap the x and the y axis. But let me show you real quick what an arc or inverse function. And by the way, I think I put this in your notes too, but another way we could say this, y equals inverse sine, or you can pronounce and just say arc sine x. We sometimes use those letters, arc, A-R-C. So it could also say y equals arc sine x. This and this mean the same thing. And it just means I know the value. Hey, I want to find out what the angle is. All right. Now, let me show you on a graph. If I took my sine wave and I kind of switched around the x and the y axes, here's what I'd end up with, something that looks like this. So look, here's that infamous sine wave, but now instead of going left to right, it goes up and down. And why might I have some trouble calling this a function? Hopefully you guys can see that's tricky to call a function because it would definitely fail the vertical line test. And so because of that, there's something that math people do, and worldwide this is accepted. In fact, I'll show you in a second, your calculators know to do this. We come up with a set of principal values. All right, let me draw some axes here. All right, there's some x and y axes. Now I know back with a regular sine graph, the amplitude is 1. Sine would go up in y to 1 and down to -1. Well, that becomes my x values. So sine goes as far to the right as +1, as far to the left as -1. And then my y-axis, which used to be labeled with 1 and -1 or whatever the amplitude is now going to have all of the angles, pi over 2 and pi, 3 pi over 2 and 2 pi. Problem is this, all right? let's say I wanted to ask the whole class, I had the whole class out there, and I wanted to ask an arc sine question. Let me see if I can label this y-axis just a little bit. This here is pi over 2. Hopefully you guys can see that well enough. This here is pi. This here is 3 pi over 2. And this here is 2 pi. All right. And so I want to ask the class a question, and I say, when y, no, I put in my x term and I get my y term. So I say, well, when x is 0, when the value of sine is 0, I want you to tell me what the angle is. And some of you will look here and say, oh, when the value of x is 0, the angle is also 0. When the value of sine is 0, I know the angle, the answer to your question, the angle is 0. But someone else says, well, hang on a second. Look right there. I think that's a valid answer. When the angle is 0, or excuse me, when the value of sine is 0, the angle is not 0, it's pi. And someone else says, well, when the value of sine is 0, actually the angle is 2 pi. And you're all right. So if I ask the question, it would be hard to ask that on a quiz or a test because my answer key would have to have an infinite number of answers, right? If you guys understand patterns, 3 pi would be a correct answer, and 4 pi and 5 pi. Also, I could go down into the negatives. I want to figure out, all right, how do I say the value of sine is 0? What's the angle? And everyone gives me the same answer. And so someone looked at that and said, well, I'll tell you what, the value of sine is at its greatest right here. It's when the value is 1. It's at its least right here. Its value is -1. What if we just cut off this piece of the graph, this chunk? And in fact, it has all of the sine values from -1 to 0, all the way up to +1. It covers all the sine values, but then everyone would have to give me the same answer. If I said, what's the angle whose sine is 1? They'd have to give me this angle here. They couldn't look for the next time that it comes or the next time or look down here. They would have to give me this answer if I just took this section of the sine graph. If I said, what is the angle whose sine is 0? Everyone would have to say 0. We'd have to give the same answer. In other words, I took something that was not a function, but by just cutting off a small piece of it, I turned it into a function. And this small piece here is called our principal values. All right. By the way, this here where sine is -1 is negative pi over 2. So if I just went from an angle of negative pi over 2 to positive pi over 2, I've got all of my sine values covered, and I could confine my questions just to that. So for that reason, the principal values of sine are from negative pi over 2 to positive pi over 2. Covers all my bases, and it works just fine. And so also that works for tangents. And by the way, if it works for sine, it works for its flip. Do you remember that's cosecant? If it works for tangents, I'm telling you it works for tangents. It also works for that flip, cotangents. We get everything covered from negative pi over 2 to positive pi over 2. And so those are the principal values, what we call the principal values when we do that. Some textbooks still do this. By the way, there's a little hint or symbol that you've got to only be talking about principal values. When it says y equals arc sine 0. Remember how I would read this again. Y equals the angle whose sine is 0. All right. Everyone notice I used a capital A. When you start to see capital A's, or if I wrote this as sine to the -1, 0, still y equals the angle whose sine is 0. If I use a capital letter, it means we're talking about just these principal values. You can only give your answer from -pi/2 to +pi/2, right? When we do in this lesson, all of the arc functions that we do, we're going to talk about principal values. And we're going to find out how we've got to be really careful about that sometimes. Now, the other trick to this is that cosine doesn't behave quite the same way. And I want you, the easiest way to show you this is to look at your trig wheel. So make sure you take that out. I told you this lesson right now is mostly instruction, not going to do a whole lot of examples, but just to make sure that we see this in practice, I hope you have your trig wheel. I hope you have it labeled. So if I say, what is arc sine ½ Okay. Remember how to translate that. What is the angle whose sine is 1/2? What is the angle whose sine is 1/2? Now, if I look at my wheel, and hopefully you guys have your wheel labeled correctly, remember that sine is the y value on unit circles. And so I look at that, and if you were to give me the right answer using principal values, the answer you would have to give is pi/6. Pi/6 is the angle whose sine is 1/2. All right, so the answer to this is pi/6. All right, if you've got your circle fully labeled, you might also say, well, another answer to that, another angle that fits is 5 pi/6. Everyone find that angle. 5 pi/6. I see that the y value is 1/2. I think that is also a correct answer. What's the problem? It's not in my principal values. My principal values go from kind of the bottom of that circle. I know it says 3 pi/2, but if I went backwards, that would be -pi/2 up to the top of the circle on the right-hand side. Those are all my principal values. All of my answers are going to be over there. Okay. The only tricky thing is instead of 11 pi/6, everyone find that angle. When I do these principal values, I go backwards. I would call that -pi/6. Okay. 7 pi/4, I would call -pi/4. We'll practice a little more of that. It's not too bad. The problem or the issue I want to show you is those principal values from -pi/2 to +pi/2. They work great for sine and its inverse. They work great for tangent and its inverse. Not so great for cosine. Okay. If I said, what is the cosine, or let's do it this way. Instead of writing arc, I'm writing this -1. They mean the same thing. Arc cosine. Let's stick with this. What is the angle whose cosine is 1/2? That's what arc cosine means. And I look and I see, well, at pi/3, the cosine or the x value is 1/2. I think the answer is pi/3. And someone else says, yeah, but you know what? At negative pi over 3, it's also 1/2. I've got two answers. If I use the same range of principal values, I have two answers, and Ms. Reagan wants to be able to ask the question so that everyone gives the same exact answer. And so for that reason, cosine has a different set of principal values than sine and tangent. All right, cosine is going to go from 0 all the way to pi. If I go from 0 all the way to pi and use that as my principal values for cosine, so when I do arc cosines, I can only look at those angles. And then I ask you this question: what is arc cosine 1/2? What's the angle whose cosine is 1/2? Everyone is going to have to tell me pi over 3 is the only answer. Okay, look at 2 pi over 3. That's negative 1/2. Not positive. I didn't want that. I wanted arc cosine 1/2. And so that might be the most confusing thing about principal values. Hopefully you understand we've got to pick kind of a window of values so that when we do these inverse things, we can call them inverse functions. We have a function. We don't have more than one answer to spit out. But the principal values for sine and its flip cosecant, for tangent and its flip cotangent, the principal values are from negative pi over 2 to positive pi over 2. For cosine, the principal values are from 0 to pi. And we'll get to practice all of those in a little bit. The bottom line is you can do arc functions more exactly than your calculator, because a lot of these angles that we're looking for have pi in them, which is an irrational number. So your calculator is going to say, oh, it's approximately this. At least for the special angles, we can give them exactly, and it's just using this wheel, and it's just going backwards. Instead of me telling you pi over 4, what's the sine of that? And you would look at your wheel and you would say, it's root 2 over 2. This time I would say, what's the angle that has a sine of root 2 over 2? What's the angle whose sine is root 2 over 2? And you look for where the sine is root 2 over 2, and you say the answer, the angle, is pi over 4. All right. And again, you could punch some of this stuff into your calculator, because your calculator, take a look at that. And when you have sine, cosine, and tangent buttons, right above them, when you hit the second button, you see sine to the -1. That means arc sine. Cosine to the -1, arc cosine. Tangent to the -1, that's arc tangent. So you do have buttons for that, which is helpful, especially if the angles are not some of these special angles that we've kind of learned. We're going to have to rely on that. We're going to have to round off a little bit. But for these special angles, we're going to give exact answers just by looking at this wheel and just by going backwards. So we'll practice a few of those. We've had a long video. Hope you guys got some of this. In the next video, we'll do some examples and some practicing.